All right, so on this one, it says a fair die, just a standard die, is rolled 4 times. What's the probability that a 5 is obtained on at least one of the rolls? Okay, so those are the key words, at least one or at least once. So there's a direct way to do it, and that's going to be the harder way. And there's a cooler way to do it. That's a lot easier. Okay, so here is the slow way of doing it. I really recommend you don't do it this way. So, so we're saying, what's the probability that what is rolled it, is let's see, probably that a 5 is rolled at least one of the times. So probability that we roll a 5, one, well, okay. So you do probability, you do a 5 one time, times probability, you do it 2 times, times probability, do it 3 times, times probability, do it 4 times. And now each one of those is going to be made up of multiple probabilities, and it's going to be a royal pain in the rear. Okay, so here's the easier way. Okay, we could use what's called complement, and we've seen that before. Okay, so we could say, well, what's the opposite of rolling a 5 at least once, one or more times? Well, the complement of that would be rolling a 5 0 times. If you don't know cursive, well, you need to learn that. Okay, that would be the opposite of rolling it at least once, doing it 0 times. But that's not what we want. In fact, that's the exact opposite of what we want. So we're just going to say 100% minus that. So if we take, because 100% represents all possibilities, and if we throw away the only thing we don't want, then what we will be left with is exactly what we do want. Okay. So rolling a 5 0 times, that means rolling 5 complement, or not a 5 on the first roll, and on the second roll, not a 5, and on the third roll, not a 5, and on the fourth roll, not a 5. So what's the probability of not rolling a 5? Well, there's 5 ways to do that out of 6. You roll either a 1 or a 2 or a 3 or a 4 or a 6, 5 ways to make that happen. Okay, times, same thing for this one, because these are independent events. I mean, whatever you roll on a die, it's not like you can say, oh, I rolled a 2. I'll just keep that 2. It's like, no, the 2 is still on the face of the die. you can roll it again. And then let's see how many decimal places. Okay, so then we get 0.518, or a 51.8% chance that that if you toss the die 4 times, you're not going to, or you'll get a 5 at least once. Okay, so yeah, about half the time. That seems reasonable. I mean, yeah, you toss a die 4 times, it's like, yeah, you frequently get at least 1 5. But this right here is the key to doing it a lot easier when you see the at least 1. Okay, that's the key. Okay, so now we're going to practice dependent events again. Okay, I know it's dependent because it talks about without replacement. So there are 10 women and 9 men with a chance to be on a game show. Oh, pick me, pick me. The producer of the show is going to choose 13 of these people at random to be contestants. What is the probability that the producer chooses 8 women and 5 men? Okay, 8 women and 5 men. All right, so we're saying, okay, we're going to pick 8 women out of these 10. So we're going to pick more than one item out of that group. Same thing for the men, more than one item out of the group. Therefore, we're going to need to go back to permutations and combinations. So does order matter here? Does it matter if you pick woman number 1 first, then woman number 2, or woman number 2 first, and then woman number 1? No. All that matters is, were you chosen or not? Do you get to go on the game show or not? So we're going to do combination. All right. Now, this is a probability. So So we're going to have a numerator and a denominator. So in the numerator, we're going to say for the women, out of 10 women, we're going to choose 8. And out of 9 men, we're going to choose 5. Okay, so that's the number of ways that this event can happen. Remember, the denominator for any probability is just the total number of things that could happen, whether it's the event we're interested in or not. So that would be out of 19 people total, we choose 13. Okay, and at 3 decimal places, we get 0.209, or about 20.9%. I know that they don't want the percents; they just want the decimals typed in. But I think it's worthwhile pointing out that right there. So about a fifth of the time, if you just pick people at random, if you pick 13 people at random in this group, you're gonna get what you're looking for about 1/5 of the time, 20% of the time. All right, so on this one, 5-card hand is dealt at random, and of course, no replacement. Otherwise, it's pretty weird. It's not how card games are typically played. What's the probability that the hand contains exactly 3 clubs? Okay, so we're going to say that, again, it's probability, so it's going to be a big fraction. So the total number of things that could happen is out of 52 cards, choosing 5 of them. So this right here will give us the total number of ways you can pick 5 cards. Okay, and wow, that was really, really weird. Something really weird just happened on my phone. Okay, so all right, so we have that, and then okay, so now the numerator, of course, is number of ways that you can actually have that event happen. So out of 13 clubs, 13 combination 3, that's the total number of ways you can pick 13 clubs. And then we need the total number of ways to pick our other 2 cards. Well, if there's 13 clubs, that means there's 39 other cards. And how many ways can we pick 2 out of those 39? This would be a setup. And you end up with, let's see, nearest hundredth. So 0.08, so about 8%. About 8% probability you draw 5 cards at random exactly through your clubs. No more, no less. Okay, on this one, they're just saying go find the event. Okay, so we're not finding a probability, just go build the event. All right, so we've got 7 tiles. Each one has one of the first 7 letters of the alphabet. So that's A through G, alpha through golf. So an event X is, well, it's something before D, so ABC. That's it. And then event Y is, you pick a C or an A or a G or an E. So what would event X and Y be? Well, and means multiplication, but multiplication doesn't make sense here. Another interpretation of and is intersection, or what do they have in common? So what do sets, let me write that down as well. So event X is A, B, C. I know I sound like I'm in a hurry. We're heading out to go watch Top Gun here in just a few minutes. All right. So what do they have in common? Well, they both have an A and they both have a C. Okay. Now X or Y means take everything, keep everything from the 2 sets. So A, B, C. And then if we look at the word cage, well, we already have the C and the A, but we don't yet have the E and the G, and you don't have to have them in alphabetical. But that's traditional, I guess. And then it says the complement of X, everything that is not in X. Well, X is ABC, so the complement would be D, E, F, G. Okay. And that's it for that one. So for this one, we got 6 balls numbered 1 to 6, placed in a bag. Some are gray, some are white, as shown below. Oh, good. I can tell the difference, even though I'm colorblind. All right, a ball will be randomly selected. What's the probability that the number 4 is selected? Well, there's only one way to get a 4 out of 6 choices. Boom, that's it. That was pretty easy. Part B, what is the probability that the number 4 ball is selected, given that the selected ball is white? So this is, we're getting into what's called conditional probability. So it says, given that it is white. So in other words, we say, okay. So you reached in, you pulled out a ball with your eyes closed, and somebody says, all right, the ball you picked was white. You say, oh, okay. So I know it's none of these. Now what's the probability? Well, the probability is no longer 1/6. Now there's only one white ball out of 3 choices. Okay. So that condition, the condition of it's a white ball, that affects the probability. Okay. And so, yeah, and I definitely like conditional probability. So there'll be, one of those on the test.